Good morning. It's a lovely, lovely day. We're going to do another Sudoku today. I just want to reiterate that anybody who wants to try these Sudokus on their own while you're watching this, just feel free to pause the video and do it along with me um, at any point in time. So you can just start doing the Sudoku before you even start watching this. Well, too late now. But just stop at any point in time if you want to work through some logic yourself, and then maybe I'll get lucky and find some of that logic later on too. Good. Okay. So this is called Disorienting Hits by Sven-Ole Behrend. I hope I'm pronouncing that right. Normal Sudoku rules apply. So that's the digits 1 to 9 in every row, every column, and every 3x3 box. If two digits are separated by a black dot, then one is double the other. So that's here. These are in a ratio of 2 to 1. So one has to be double the other, or you can look at it, one has to be half of the other. So for example, if this was a 4, then this would be either a 2 or an 8. Beige lines or hit lines? I'm not really familiar with this. This is something I'm going to have to learn about. Beige lines or hit lines? Lots of them. Digits along a hit line do not repeat. Okay, so like this can't repeat here, for example. All of these are going to be different. One end of the hit line to be determined by the solver is the starting point. One end of the hit line. One end. The digit n in the starting point, one of these cells, indicates that exactly n digits along that hit line match their position along the hit line. Does that mean like position 1, 2, 3, 4? Counting from the starting point. Example, a valid hit line of length 6 could be given by 4. Okay, 4 would be the starting point, it says. So it would be 4, 2, 3, 9, 5, 6. So it's of length 6. The digit n in the starting point indicates that exactly n digits match their position. Yes, okay, because the 2 matches its position. It's the second position. The 3 matches its position. Like, is there a 6 one I can use for an example? No, not really, but like, there's a 7. Or like, maybe I'll use this one. This is a 5. Let's say this one's the starting point. That means if this was a 3, then this is the first position, this is the second position, third position, fourth position, fifth position on this line, on the hit line. But that would mean that 3 of these cells match their position. So maybe this could be 2, oops, some color mode, 2, 4, 5, and a 9 or something. That means that this is the starting point, and this digit matches its position, this digit matches its position, and so does this. 3 of them do. So that could be a valid way of putting this line in. Is that it? I think so. I think so. Okay, let's get started then. Restart, got the time going here. So on each hit line, the starting point, which we don't know where it's going to be, it's one of the ends. The starting point can only be a maximum of the length of that line, right? Like in this line. Like this on this line, the maximum number of cells where the digit in that cell corresponds to the position, like the order, is 4. Like if you made this 1, 2, 3, oh no, it's not even 4, because 4 actually would be impossible in that case. Does that apply to and the reason is because if you're saying that the 4 is the maximum number of matching digits, that means 4 is the starting point, and by definition doesn't match position 1. Like that would be position 1, and it's not actually matching it. So the largest you can make this, the most you can make these match is 3. But interestingly, I don't think 3 would work either. If 3 was the starting point has to be a 1, 2, 3, or 4. Might be the cell, but I'm just going to put it in here for now. It can't be a 4. We just figured that out. I don't think it can be a 3 either. Because then if this is the starting point, it's position 1, so it does not match. All 3 of these would have to match its position. That means this would have to be 2, 3, 4, and we'd have another 3. So actually that doesn't work. 1 by definition just would work because it's matching its position right away. What about 2? If it's 2, then that doesn't match, and neither would this, because it can't be another 2, and it would have to be to match its ordering. So this would have to be 3, 4. Okay. So it's not 3, it's a 1 or a 2. Maybe I can do that. I wonder if I should color it too to kind of make it obvious, yeah. And if it was a 1, then these could be anything. If it's a 2, then there is a 3, 4 pair in here. Maybe that's going to be impossible. I think that might be impossible because, like, I wonder if this is going to have to be. Oh, 1, 2, yeah. The starting point on this can't be a 5 either because the same thing, the same logic applies. If the starting cell has to be a 1, 2, 3, 4, 5 because, again, the number indicates how many match with the order, how many digits match with their order along this line, starting from the starting point. So this can't be 5 because then it already doesn't match its order, which is 1. Position is the first position. So it's going to be, and again, I don't think it can be 4. Digits on a hit line do not repeat. Okay, just making sure. Can the hit line start with a 4? No, because then that doesn't match. And you wouldn't be allowed to put a 4 here because of the no repeats rule. So you'd only be able to get a maximum of 3. So sorry, this wouldn't be a 4. This would be something else. Like X, I don't know. Anyways, this could not be a 4. So these 3 could match, but that wouldn't equal 4. Okay, so I'll make a little thing. Could you do 3? If it was 3, then you'd have to do 2, 4, 5. Because the 3 wouldn't match, and then the third position wouldn't be able to be a 3. So the other 3 would have to match. So if that's 3, that's a 2, that's a 4, that's a 5. And it would be the same if the starting cell was here too. 1 is going to be possible for sure, no matter what. It just means that matches, and these can be anything. They just can't. But they cannot match. Anyways, 1, 2, 3. So I'm going to do it kind of like that. Hopefully, I don't get confused by my corner pencil marks. What about, I wonder if there's like something in a row we can look at, you know? Like there's a lot of starting points in this row, eh? Potential starting points. So there is a starting point in one of these, and actually none of these have to be starting points. Starting point here. Well, maybe this can't be a starting point. Nah, it probably can. 1, 2, 3, 4, 5. So whatever the starting point is, I think the same thing. I'll make it blue. I think it again can't be 4. Yeah, it can't be 4 for the same reason that we went through with this. And it can't be 5 for the same reason. So this is also 1, 2, 3. Whichever one this is. I don't know which one it is. Maybe I should do this too, eh? Because I don't actually... Let's just do that. Hopefully this doesn't get too confusing for me. Is there any difficulty about this one being 3? If it's 3, then that's not a 3. This would be like 2, 4, 5. Sure. Okay. This one's huge, eh? 4, 5, 6, 7. So, and they can't repeat, which is interesting. So I mean, these are a lot. These are all different cells. 7 different cells. You cannot. Oh, this could be. You know, you can have this. I don't think this is going to be helpful right now, right? Because you could make it a 1. The starting point could be a 1. It can't be a 7 because then the 7 wouldn't match. But it could be anywhere from 1 to 6, I think. No, 6 wouldn't work either then because 6 would be in the wrong position from the starting point and also wouldn't be allowed at the 6th position because you can't repeat it along the beige line. So you can't do a 6. It's 1, 2, 3, 4, 5. I mean, sure. Maybe I'll just do it like that. Sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. Wow, 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 wow. Wow, 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 wow. So this is another region of the puzzle. These are all different digits, so they are the digits 1 to 9. In some funky order. 1, 2, 3, 4. Let's make this a red color. What's that going to be? So this is going to be, again, not 4, not 3. So this is 1 or 2. That's any 4-cell line does that. What does a 3-cell line do? We haven't looked at that yet. Okay, this is going to be orange. The 3-cell line cannot be a 2. It's going to be, 1 would work because it'd be in its own position. And then the other 2 could be whatever, as long as they don't match. 2 wouldn't work because 2 wouldn't be in its own position, and you couldn't put a 2 in the 2nd position. So 2 doesn't work. So it's 1 or 3. Does 3 work? No, 3. Oh, it's just 1. 3 doesn't work. Since 3, that means that all of the cells are in the correct position, but 3 wouldn't be. It'd be in the 1st position. So this one actually is a 1. Okay, maybe I need to think harder about whether this can be a 2 then. Because if this can't be a 2, then this can't be the starting cell at all. If this was a 2, then these 2 would have to match. Like, because this couldn't match, it would be in the 1st position, and then you couldn't put a 2 in the 2nd position. So this would have to be a 3 and a 4. Which means that either this is a 4, or it itself is the starting cell. Like, one of these is the starting cell. If this is the starting cell, it's a 2. Can't be a 1. It would be a 2, which would make this a 3 and this a 4. But if this is the starting cell, it's a 1 or a 2. So this can only be 1, 2, or 4, which is kind of interesting for this. And I'm not gonna go there though. And if this is the starting cell, it could be a 1. Could be a 2. Okay. Oh yeah, here we go. This is I should have looked at this earlier. So this, oh, I gotta be really careful about this pencil mark, eh? Because this is a true pencil mark. This is like, this cell can actually only be 1, 2, or 4. These ones, oh, that's gonna be hard to remember. You know, maybe I'll just do this again. Yeah, I'll try like that. I'll get rid of these and do that again. Just to kind of remind me that this central pencil mark is true, and the 1 and 2 mean that those are the options for the starting cell. So 1, 2, 1, 2, oof, 1, 2, 3, 4, 5. What a pencil mark, eh? 2, 3, 4, 5. But hello, hello. This here, what color? Gray, I guess. Same thing. This can't be a 3. Just like the logic we did here, can't be a 2. So it is a 1. That means this one cannot have a 1, so this has a 2. And maybe, you know, maybe if this one's, if it's here, if the 2 is here, it's going to be trouble for that. But let's finish the logic on this. So, well, that means this one can't be a 2, right? So it's either a 1 or a 3. So if this is a 2, whichever one is the starting 2, if it's this one, then it's in the wrong position, and you can't put a 2 in the correct position, so the other 2 have to be a 3, 4. Like this. In the other situation where this is a 2, so that's if this is a 2. If this is a 2, then these 2 are 3, 4. And the other one, whichever one, like, if this is a 2, this is 3, 4, and this can be whatever. It just has to be something different than a 2. But we do have a 2, 3, 4 triple in here. It's a 2, 3, 4 triple. The 2 is in here for sure. And now this can't be a 3. So this purple has a 1. Yeah, so that means none of these match. Is that going to help us? That means this, that means neither of these can be a 5. I say neither because if one of these was a 5, then the other one would have to be the 1, and it's in the proper position, but it's also saying that nothing else can match besides the 1 in the first position, so the 5 wouldn't be allowed to be in the other one. So 5s are not allowed in here. A 3 is not allowed here. Well, no, we already know that. Those are done. Yeah. Well, I guess that just tells us, yeah, that this, in this region, in this 5-cell beige line, none of the other cells can match their position. So it's not really a strong constraint that we can do anything else with. Like basically it's saying this is anything but a 3. This could be a 5, 6, 7, 8, 9. I guess that's all. And then we do have a 1, 2, 3, 4 pair in here. So like all of these are from 5, 6, 7, 8, 9. But that doesn't really rule much out, you know. So something might happen, like you might get a problem with, it's not necessarily, what I just did there wasn't necessarily true with the 3, 4 pencil mark. So what does this do, eh? So what would happen if this is a 3? That might be problematic. Yeah, I think it would be. If this is a 3, then the starting point is not a 1, it's a 3. And like, maybe I'll just actually put it out just to make it a lot more obvious. So if this is a 3, then it's the starting, like, sorry, I'm saying if the starting point is a 3. If the starting point is a 3, and let's pretend it's here, doesn't really matter. That means it's not a 1, so it's not matching, but 3 have to match. The third position won't match because it's right here. No matter which side you come from, this is the third position. So that won't match. That means these would all have to match. This would be a 2, 4 pair, and that breaks because this cell won't exist. You'd have to put a 2 here and a 3, 4 here. You'd have 5 cells from 3 digits. And just to prove my point, if you put the starting point here and it was a 3, same thing. This couldn't be a 3. This couldn't be a 1. So these would all have to fit. This would also be a 5 to make 3 of them match. And in the other case where this was a 3, this one would be a 5. But again, 2, 3, 4, broken. So all that to say, not a 3. What about a 2? A 2 might be possible. It might be possible. I just saw something else silly. That's not a 1. I had that a million years ago, and I just like, this is a 1. Okay. Okay. That's 1. And it is the starting position then, right? Because we determined that the starting position in that one has to be a 1. So that's, sorry, that is the starting position of purple, and this one isn't. So now this yellow one can't be a 1. Neither of the potential starting points can be a 1, so that's not it. The starting position can't be a 1 on this one either now, so it's a 2. So one of these actually is a 2, which means this is not a 2. So this is a 2. This is the starting position 2. Now this, I can get rid of that flash. I can get rid of that flash. This is a 3-4 pair now. Both of these now see a 1, 2, 3, 4 quadruple. This one sees 1, 2, 3, 4 in this box. This one sees 1, 2, 3, 4 because this is a 2. So this is a 5. Whichever one it is, it's a 5. 2, 3, 4. So that's a 5. What's going to happen with the 2 here? It might be difficult to make these match, eh? Because if the 2's on the starting point, regardless of where the starting point is, the second position is either going to be here or here, won't be able to be a 2. And also you can't repeat the 2 on the line anyways. But so that won't be in the right place. The second position won't be correct. The first position won't be correct because it'll be a 2. The fourth position won't be correct because there's a 4 here. And one of these has to be the fourth position. From this one, it's like if it was here, it goes 1, 2, 3, 4. And if it started here, it goes 1, 2, 3, 4. So the fourth position won't be correct. So that means the third position has to be correct and the fifth position has to be correct, meaning this is a 3. It's the third position, no matter which way you come from. And the fifth position is whichever one of these isn't the starting position. So this is a 2-5 pair. Whoa. But we don't know anything else. Yes, we do. This one cannot be a 5 anymore. So this is the starting point for yellow line, the line that I've dubbed yellow. That's an actual 5. That's just gone. This one can still be a 2, right? Can it? If that's a 2, that's a 5, that's a 2. I'm trying to figure out if this one on the red line can be the starting point, because I said it had to be either a 1 or a 2. It can't be a 1. If it was a 2, this becomes a 5, this becomes a 2. That seems okay. And if it's a 2... No, it can't. No. Because this 3 rules this square from being a 3. Because if this was the starting point and was a 2, then neither of these match. We need two of these to match their positions, 2 of the digits to match their positions. This can't, because this is a 2, and then this therefore is not a 2. So then this would have to be a 3, and it can't. So this is not the starting point. This is the starting point. And it's not a 4 then. 4 was in the case where this was the starting point. So this is a 1 or a 2. I'll probably get rid of that now. And is it the same thing if it's a 2? Then that would be 3, 4. Now it's different. Because if this is a 2, then both this cell and this cell would not match. We'd have to make 2 of them match. So this would be 3, this would be 4, which would work. And if it's a 1, then these can be anything. This can't be a 1-2 pair anymore. But it could still be a 2-4, just because it would break this cell. But it could still be a 2-4, a 4-8, or a 3-6. Is this limited? This is the starting cell. Maybe I can find some other ones that won't be able to fit. Like this is the 7th position. This is the 6th position. Oh, of course. This line is like done. This is the 5th position. But you already have a 5 on the line, so 5th, this won't be allowed to be a 5 by the rules. So, and then this 5 doesn't match its position because the position is the 1st position. So these are both not matching, but we have to make 5 of them match. So all of these have to match their position, starting from here as position 1. So this is a 2. It's going to fill in lots of stuff. 2, 3, 4, 6, 7. So that's 3 now. This is a 4 now. This is a 3. 6 is up here now. I'm just going to fill these in now. 6. Can I fill these in? What are they, 6, 8? Oh, this is a 6. Where do you put 6 in row 2? Not there, not here, because of the 6. So that's a 6. This is an 8-9 pair, which doesn't do This is a 7-8-9 triple, and they have to be different. On each beige line, digits along a hit line. Can I? Oh, I can't highlight that. Digits along a hit line do not repeat. That means these are all different. So that means that this can't be a 7, 8, 9 or a 1. It also can't be a 2, 3, 4. So this is a 5 or a 6. That's interesting. Also, it means that there's a 7 in here, so there's no 7 in here, because there has to be one in here. There is a 6 in here. 7's there, 7's there, so there's a 7 up here in box 3. Can we figure out what else is in there? And there's a 2 in one of these. I think that's all we can do there. All we know about this is that it's not a 5 or a 2, 4 like the other things by Sudoku, but this can still be lots. No, it can't be lots of things because you still can't repeat anything on the line. So it's a 1, 2, 3, 4, 5, 6, 7. What's a 1, 8, or 9? Maybe this one's going to be hard now? Probably, eh? Probably. Is it? Is it going to be hard? Maybe some more Sudoku. 2, 2. 2 actually can't go here, because then it would be matching its position, and so would the 1. So 2's here. 3? I mean, sure, 3 can go there. So 3 isn't any of these. 4 isn't one of these. I think that's all I got there. Does 3 change anything? No, this can still be a 3, this can still be a 4. Maybe we're limited in where we can put something in this, because this has to be all the digits 1 to 9, because you can't repeat anything on the beige line. So are there any of these that are difficult? Whatever this is ruled out of all of these cells. So it has to end up in one of these places. If it's a 1, this one, it wouldn't be able to be here either. So if this was a 1, you couldn't have a 1 in any of these. This was a 1. Oh, it's not a 1 because of that. It's an 8-9 pair. What's that going to do? Anything? Oh, I see something kind of weird. So this cell has to be in this box, has to be in this triplet, because this is a set of all the digits 7, 8, 9, because they're on the same beige line. So they have to be 7, 8, and 9. This one is definitely not the same as this one, because it's in the same box and the same row. Like, they're not identical. If this is an 8, that's a 9. If that's a 9, that's an 8. So that means that whatever this is, it is one of these. And that means it's also up here. So this is 7, 8, 9. Cool. So now we have a 7, 8, 9 quad, and this is what's left over. So there's a 1, there's a 4, and there's a 5. That kind of surprises me. I didn't think that was going to happen. So this is 2 and 3. And what's in here now? There's a 4, there's a 1, and an 8, 9. I mean, I guess I could do that. 1, 4, 8, 9, and the 1 and 4 are definitely in there. It's so messy. I don't like it. I can do that. I mean, that's messy too. I don't like that either. This one is the same as this one too. If this was 8, 9, then these two would both be the 8, 9s, right? Like if this was 8, 9, then this would also be the same digit. And then it would be here. And here. Seems okay, actually. But I was thinking there, like if this was 8, 9, then because these are the 3 digits together, like these are 7, 8, 9 triple, this, let's call it A, whatever it went, it's not 7, it's A, then this would be the A. Oops. Then this would be the B, so this would be the A. So it would be really hard to put A on this line. It has to go on there somewhere. So this would be the A. B. D would be one of these. Because this would be the 7, right? B, I don't know. I mean, somewhere in there. Backtracking. Okay, let's see if we can find some more fruit here. Fruit to harvest. Some more yield. 2 and 3. So 2 and 3 are down there. Let's just do that, whatever. What the heck can these be? Not 1, 2, 3, 4. Like, you can't make it a 9 because then that implies that every single, if the starting point is a 9, then it's already failed because it doesn't match its position, and only maximum of 8 could match their positions. What if it was 8? Then the rest would have to match. So you'd have an 8, 9 pair in here. No, it wouldn't work then, because then the 8th position wouldn't be able to be an 8 either. So it's not an 8. If it was a 7. If it's a 7. I don't think it works, you know, because I think if it's a 7, that gives us the same situation in which this becomes an 8, 9, and then this would be the same, this is a different digit from this, so this would be the same as this. So now it's really hard to put that digit into this beige region, this big 9-cell beige region, but it has to be somewhere. So it would have to go here, out of position. So the 7 would be out of position, it'd be in the first position. And then you couldn't put, oh, but it is the 7th position. Oh, I was gonna say, because you couldn't put, like this would be out of position, but also the 7th position. That would make 3 things out of position. And you can only have a maximum of 6 in position then. So, but this actually could work, eh? Let's see. That means that everything else would have to match though, because the 7 would not match. This, whatever it is, would not match, because this is either position 3 or position, the opposite, 9, 8, 7. This would be position 7. So everything else would have to match. Like if this was a 7, we'd have to do 2, 3, it already fails because that would break this cell. So this can't be a 7. Could this be a 7? If this was a 7, no, because then this would be in position 3. So this would be wrong, this would be wrong, and then position 7 wouldn't be able to be a 7, so that'd be wrong as well. So you can't do 7 at all. So it's a 5 or a 6, whichever this one isn't. Maybe 6 is hard as well. Because if you do a 6, 2 of them are already missing. 2 of them are already out of place. Sorry, this one's not actually true. I gotta go back to my logic. That was only if there was a 7 in here. So if you have a 6, then as a starting cell, then the starting cell's out of position. And then also the 6th cell won't be able to be a 6 anymore. So 1, 2, 3, 4, 5, it's either this one or this one. 1, 2, 3, 4, 5, 6 from this direction. 1, 2, 3, 4, 5, 6 from this direction. Neither of these would be able to be a 6 because there's already a 6 on it. So that's missing. So then we'd have to get you'd have to miss one more. One more of them could be out of place. We may be able to rule it out. If this is a 6, then this would be the 7th position. 1, 2, 3, 4, 5, 6, 7. Sorry, 7. And that 7 cannot be a 7 because of this 7 here. So this would be out of place. You wouldn't be able to put a 6 here, and this can't be a 7. So if this was a 6, everything else would have to fit, and this would break because this would be a 2, 3 pair, and that breaks this cell. Okay, I'm just gonna write that out just so like I understand it. I just want to make sure it's visibly understandable. So like if this is a 6, it's in the wrong. If it's a starting point as a 6, it's in the wrong position already. This would be the 6th position, which can't be a 6 again because there's already this on the line, and then this the 7th position, which can't be a 7 because there's a 7 in the column. So everything else would have to fit. Three of the 9 cells are not fitting, so you need the other 6 to fit. So this would have to be a 2, 3, and that breaks this. So let's just go back. So that can't be a 6. If this was a 6, then this is out. 1, 2, 3, 4, 5. This wouldn't be a 6. So these both would be out. Maybe I'll just do like black. Those are out. Mr. Black. Let's see what else might be missing. This could be a 2. This could be a 3. This could be a 4. This could be a 5. This couldn't be an 8 because we have an 8-9 pair here. So that one's out. Okay, so the rest would have to fit. So it'd be, this would be a 9. Maybe 6, 9. 8, 7. 2, 3, 5. But this would have to be 2, 2, 3. 4, 5 takes away that. That'd be a 1, that'd be a 2, that'd be a 3. 3. No, the breaks actually, it's funny. It's weird, but so it's very convoluted. If this is 6, then all 3 of these won't fit, but then you'd have to put a 2, I'll just write it in now because I understand. 2, 3, 4, 5. And the 4, 5 is what does it, because then this isn't a 4, 5. This would be a 1, this would be a 2. Oh, also that. But I was looking at this. This would be a 3. And now where do you put 3 in here is what I saw. At first glance, you might think, oh, it could be here. Like this 3 rules it out of there, so it could be here. But you can't because it's already on the line. So that doesn't work. All that to say, that's not a 6. It's a 5. That means this is a 6. What's a 5 gonna do? I mean, same deal. Like I wonder if this is a way to do this. This just seems really convoluted. If this is a 5, there still are going to be 3 things missing. Like, now that I recognize this 8-9 pair, either this is the 8th position or this is the 8th position, so it's not going to be correct. So maybe we can rule out if this is the 5, because then this would be the 7th position and this is the 8th position. They'd both be wrong. This would be wrong. The 5th position would be wrong. They'd all be wrong. Okay, this might be easier to rule out. Maybe. If that's a 5, then we got, then this is wrong. We need 5 of them to be right. So this is wrong. The 5th position won't be able to be a 5, so that'll be a wrong. This won't be able to be a 7. This won't be able to be an 8. So these would all be wrong. So this would have to be 2, 3. Yeah, that's wrong. That's wrong. Because again, same thing, the 2, 3 thing. So this is the 5. 1, 2, 3, 4, 5, 6. Okay, so this is wrong. Okay, I'm gonna actually like mark down what's wrong now. So this is a 5. It's wrong. This, wait, 1, 2, 3, 4, 5. This is in the wrong position, whatever it is. That's not, just ain't gonna fit. I wonder if this just can't be a 1. Maybe this just can't be a 2 because you have to put a 2 here. Anyways, let's keep going. This is going to be wrong because it can't be an 8. Is there anything else going to be wrong? Like this could be a 9. This could be a 7. Although if this is a 7, then this has to be a 7, which is a little tricky, but it's still doable. Because it can't be on the same line again. And by Sudoku, it would be there. This would be 2, 3, 4. I don't want to start filling things in like that because it's like it's divergent. It's kind of like cheating. Like you just fill things in until something goes wrong. And then you just automatically will find the answer. So like I don't want to start filling things in. I want to be able to see it logically. 6. Where does 6 go in this then? 2, 3, 4, 5, 6. I guess lots of places. So 5 in here. This 5 can't be on this line anymore, and it can't be in here by Sudoku, so it has to be up here. That means there's 5 in here. Maybe, can this be a 2? If that was a 2, then this was a 3. Four. It's fine. This one? Where does it go in this box? Or in this region? It's either there or there. Whatever this cell is, it can't be in any of these cells. So it's either there or there. Any other restrictions on these guys? Like, I don't think so. This could be anything, as long as it's wrong. Well, you can't put a 3 in here then. And you can't put a 3 here. Ha! Okay, I'm glad I looked at that. You cannot put a 3 with this 1, because 1 is the starting cell. It is. It has to be. It can't be the 3. So 1 is the starting cell. If you put a 1-3 pair in here, that means the 3 is also in the correct position, because it'd be 1 something 3. So you cannot put a 3 in this. And by Sudoku, you can't put a 3 here either. So where does 3 go in this row? Here with the 5. So that's a 3-5 pair. Now where does 3 go? It goes in here. 3 in this beige thing is here. Has to be, so that's not a 3. 3, 3, yeah. So this isn't a 3-6, so this is from the 1-2, 1-2-4-8, and it can't be a 1-2, so it is actually 2-4-8 with a 4. It is a 4. 4, 4, 4. 4's in there. Does that help you with anything here? That's not a 4. These aren't 4s. One of these is a 4. Doesn't really help. Nothing fancy going on with the 3s here. I mean, if this is a 3, that's a 3, that's a 3. If this is a 3, that's a 3, that's a 3. There's no like X-wing potential, you know, nothing happening there. So this can be correct, this could be a 9. This could be a 7. This is 7. This can't be right, this can't be right. I don't want to focus on what they could be, because they could be anything, as long as they're not the correct digit. 9, 8, 7, 6, 5, 4. Can this be a 4? If it is, then one of these is a 4. Seems fine. What if the 3 is in the wrong position? Does the 3 have to be in the correct position? Because if a 3 is here, then if this is the 3, it would be wrong. But then you also couldn't put 3 in its correct position, so this would be wrong. And so would this. Like if 3 was in here, then you can't make this a 3, so this is going to be an incorrect matching. And so would this, because this would have to be a 2. So this is actually a 3, which is going to fix our 3s up here. Like this 3-5 is fixed now. 3, 5, 3. There we go. There we go. I think that actually was what we were meant to do, because then that 2 very clearly points to here and gives us a 1. Now 1 has to show up on this beige, on the beige line here, and it can't be there, and it can't be here. It can't be there, 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 there. So it has to be here in one of these. This 1 doesn't do anything really, because it just means these can be, it just means these cannot be correct. Well, oh, it does do something. This can't be a 3. So 3 in this box can't be there, there, there by Sudoku, and it can't be here. So this is a 3. There's a 3 down here. This can't be a 4. I don't think that helps. This can't be a 2. I don't think that helps. So that's correct. This, oh yeah, okay, this is, the starting point on this gray cell, a gray line, has to be a 1, so it's not this one then. It's there. By the power of gray cell. That's 1, that's 1. 1's in one of those. Can't repeat here. Ah, okay, okay, okay. So now we have an X-wing on 1s. So in these 2 columns, you can only have 2 1s, because you can only have one of any digit, any single digit in a single column. So in this column we're going to have 1, 1. In this column we're going to have 1, 1. So in these 2 columns altogether, you're only going to be able to have 2. two ones. And they're here and here. That means nowhere else can you have a 1. These can't be 1s. These can't be 1s. These can't be 1s. These can't be 1s. Anyways, these ones can't be 1s. So the only place for 1 in this row now is here. 4's in one of those. What's left in here? 1, 7, 8, 9. Looks like this one's not the one though. 5 in one of those. Five's not here. 1 is not here. One is in one of those. 5 is in one of these. 4 is in one of those, yeah. Can I do anything more with these? Yeah, I don't know. This one. These are wrong. This can definitely be a 4. This one, okay. One of these is a 4. Because you need a 4 on the beige line. This can't be a 4 because of this. So, like, I guess we could ask the question: what would happen if 4 is not in its correct position, which would be here? 1, 2, 3, 4. What would happen if 4 is not here? That would make this black, and the rest of these would be in the proper position. So this would be a 2. This would be a 9. This would be a 7. That seems alright, eh? This could be whatever. We could play that game with other things, I suppose, too. Like, what would happen if this isn't a 2? Then this would have to be a 4. If this wasn't a 2. This would have to be a 4. 7. This would be a 9. This would be a 4. Yo, 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 yo. Little bit flustered on this one. I don't have that much time. I gotta go soon. Driving out to the park to stay for the weekend. Can't be a 2. Can't be a 2. Maybe some more Sudoku. Let's take a look. Okay. Ones. 1, 1, 1, 1, 1, 1, 1, 1. One's on the draw position. Yeah. Wait. Have I been doing this wrong the whole time? Are those all ruled out? Oh my gosh, I'm so sorry. These are all already... Why was I thinking there was still one more to be gone? Oh, you must be just screaming at the screen. Oh my gosh, I am so sorry that you had to watch that. Four of these cells are already ruled out. There's only 5 left, and 5 are correct. Oh my gosh, I'm so sorry. I'm so sorry. I'm Canadian. Just let me go. I have to say sorry because I'm Canadian. It's part of my culture. Anyways, so I can actually fill these in now. So that's a 4. That's a 5. 5 is not there, and that's not there. 5 is here, 5 is here. Now we're just swimming along here. That means this is 7, right? 7. This is a 9. So silly. That's not a 9. That's not a 9. Fill the rest of these. 1, 2, 3, 4, 5. So it's 6, 7, and 9. Looks like. Oh, so this isn't 6 or 7. This is just a 9. This is a naked single 9. So that's a 6, 7. This is an 8 or 9. This is an 8 pair, but this 9. This can't be a 9. This is an 8. This is a 9. This is an 8. That means this can't be an 8 because they're on the same line. 7. Same logic. This can't be an 8 or a 7 because it's on the same line. That's a 9. Well, look at this. Look at this. This 8 rules this out for being a 9. And now this is going to be a triple. 7, 8, 9, 8. Why don't we fill these in? A 1. 7, 8. 7 goes here for by Sudoku. 7's out of this here. 7. 1, 8. The 1 down here fixes that. 8, 1. I was so close to getting to this point for a long time and just like totally missed out on that spot there. Excuse me. Great, yeah, that's fine. What are these? 1, 2, 6. This is not a 2. Oh, this is not an 8. That's a 4. It's an 8. This is a 4. This is a 1. Now this is a 6. This is a 1, 2 pair. This is not a 1 by Sudoku. That's a 2. That's a 1. 6, 7 is not resolved yet. It's okay though. I forgive you. 2, 4, and 5. This can't be a 2. This one here, because then it would also be in the correct position. And there's only one correct position on this line, the 1. This can't be a 4. Because then it would be a correct position, so that's not 4. What are these? 9 and a 6? Okay, we got those. 6, 9, 9, 7, 8, 4. That's interesting. 2 is down here somewhere. It's 2, 3 pair. Because 2's in one of those, 2's in one of those, so there's no 2 in any of these. That's another way to look at these X-wings. Like I showed you that X-wing before with the 1s. It means that like none of these could be 1s. But or you can say like, okay, if these were 1s, then where do you put 1 in the row 7? You know, it can't be here, it can't be here, so it has to be one of these. Same thing here applies to 2s. So you have one of these is a 2. Those are the only places for a 2 in this. Based on the pencil marking, you can only put a 2 here or here. In this box, you can only put 2 here or here. So you could mark it like that. But now you can't put a 2 here. You can't put a 2 here in column 8. So 2 has to be in one of these, and it can't be here. So this is a 2, 3 pair. I'm just going to get rid of those. Oh, this isn't a 2 by Sudoku, so that's a 2. Okay, this is going to resolve then. So that's a 3. No, that's a 2. No, that's a 3. Those are done. This is a 6 or an 8, it looks like. Try to finish these off, so it's 4, 6, 8, 9. Yeah, it looks like it. So this is not 4 or 8. 6 or 9. This is not 9. I'm just doing Sudoku, like scanning the rows. Oh. So this is 4, 6, 8 as well. Like this is a triple. This is not a 6. Oh, there's a 2-5 pair there. Look at that. But hey, wait a second. Look, there's no 5 here. What's this? Wait, no. Look, where do you put 5 in column 8? It's not there. Well, I can just do this. 5 in one of these. Oh, and the 2-5 pair rules out of there. But alternatively, like I was looking, okay, the 5 couldn't be here because of this. So in this column, where do you put 5? None of these can be 5s by the pencil marking, so this is a 5. Therefore, this is a 2. Therefore, this is a 5. Therefore, this is a 2, which was the starting point. So that's that. All of our starting points have been fixed, except I'm going to change these ones. Black was actually my way of saying which ones couldn't be correct, but this works. I'm gonna call this starting point black now. This is 2-5. This is a 4. It's not a 4. 2. I feel like I was doing something and I forgot. That 5 maybe. This 2 maybe. This 5. I lost my train. Well, 6, 8 though. That's a 7. This is 9. Not 9. Ah, 9 we can get. So 9's here and here. So it's in one of these, but it can't be on the same line as another 9 already. So this is a 9. Now this is a 6. So now this is an 8. 6 and 8 are gone. This is a 4. This is a 9. This is now an 8. This is a 6. Now this is a 7. This is a 6. This is not a 4 anymore. This is an 8 from the row. This is an 8. This is a 6. This 4 here breaks this 8, 4. So this is an 8. This is a 4. This is not an 8. This is not an 8. That's a 7. Now this is a 1. Now this is an 8. Now this is a 1. Wait, before I finish. That and that. What's that? 4, which would be here, and 7. Okay. Just under an hour, eh? Yeah, that was great. That was a really good puzzle. Really cool. I hope you enjoyed that kind of content, that kind of puzzle, and I will see you for the next one.